Hello, how are you?
Good, how are you?
I'm okay. You doing okay so far?
Yes.
Uh,
Yeah, I have some questions.
yes, go ahead.
Um, so for the week 4 projects, for
U4 project. Okay, let me
the
bring that.
performance measurements,
Yes,
you said you wanted a report. Like
we want a report. Yes.
so like how long of a report do you want? Do you just want like
You do analysis, so you report that what you have done so far in this project. So I want you to implement the sorting by yourself. Don't copy the sorting algorithm from outside. Okay. If you can, you just do coding coding out the selection sort, insertion sort, bubble sort, merge sort, and quick sort by yourself. Each one of them put into a program, into a module, a .py file, right? Just like this example, you basically put it in one .py file and run it. So when you run it, I wish you can run over different number of n numbers. And the number of n numbers you can generate by the random numbers. And then you do sorting. And then you figure out how long that algorithm go and measure the time for each sorting. And then the report just reporting whatever you got.
so I guess like
So let's assume that you have the bubble sort. You do 10 element, 100 element, 1,000 element, 10,000 element, and 100,000 element if possible. That's written here.
mhm.
Yeah. To figure out how your program grows, you have a growth rate. We want to know about the growth rate. So bubble sort, insertion sort, selection sort are supposed to be order n square algorithm. Merge sort should be order n of n algorithm. And quick sort also n of n algorithm. But the bottom line is that I want you to review the sorting algorithm. So if possible, don't copy the sorting from somewhere else. You write your own sorting if you know it. If you don't know, then there's no option. You have to source some sorting algorithm from somewhere. But that's not recommended.
Okay,
Yeah, is that clear?
that's clear. So I
Yeah.
guess like maybe like a paragraph for
And
each.
then you just do something like this, analyze the growth rate.
So I
And
guess
write
like a few sentences for each
write a simple report, okay? Don't write a full or technical report like 10 pages, 20 pages. We don't need that. We just need you to have a simple report.
so I guess like a few sentences per algorithm, I guess that sounds good.
Yeah, that sounds good. We just want to know about the growth rate and how you execute a program and your conclusion, something like that. That's enough. There's no need to discuss why there's a bubble sort or why there's an insertion sort. There's no need to talk about the history of the sorting. It's wasting time.
Okay, that sounds
Okay.
good.
Any other question?
And you said we could use a algorithm from online if we just cite it,
If you don't remember it,
if you don't remember it. Oh, okay.
okay. Only if you don't remember it. We suggest students to write the sorting by themselves.
Okay. All right, that sounds
As a computer science student, like already a senior student, writing the sorting algorithm I think, is a basic understanding that all the students, the seniors, the computer science students should be able to write sorting algorithms, right? Because you take the data structure course before, you take the algorithm and data structure course before, so are supposed to be able to coding out these sorting by student themselves, right?
right.
Yeah. If they cannot, that means that the education has some deficiency, something wrong. Okay.
Yeah, sounds good.
So the purpose of this project is still to let students exercise their knowledge in Python and really and also knowing about the relationship of the performance versus the algorithm, right? That's the purpose.
Yep.
Okay.
Did you get a message from me from Facebook from Kostas Spyro like
What
maybe a week ago?
question?
Yeah, yeah. Did you get like I sent you a message on Facebook like about a week or two ago?
Yes.
Kostas Spyro. Yeah. Did you like respond? I don't think you responded to that.
For Facebook and what? Can you repeat again? Question?
It was like about like Pi files. I think about a week or two ago.
Python. Yeah, I want everybody to put the answer just in the Python file.
But
I don't need the screenshot. I don't need that. I just need the Python program.
okay. But but you know my Facebook, right? Like I sent you a message.
I don't like the notebook, the IPython notebook. No, we don't need that.
Okay.
That's a different tool. Some students get used to it. Cannot write the Python file. We don't do that. We just want the Python file. So IPython file, we don't use it here. Is that okay?
Yes, that sounds good. But about Facebook, you received my message on Facebook like a week or two ago.
Mm-hmm.
You did?
Facebook, yes. And then what else? Facebook and what happened?
Like I sent you a message on Facebook about a week or two ago.
Yes.
Did you receive it?
For what?
It was about asking about Python files.
Yeah,
Like I can't quite remember why I asked. You know, it's been a while now, but I'm just wondering if you received the message.
I don't know. But anyway, if
Okay.
you figure out, you can ask again, okay?
Okay.
Because I don't remember. Sorry.
Okay.
Yeah.
But that's the place where I go to if I have questions. Just I message you on Facebook. Is that correct?
Yeah, I want people, if you can, if you want to contact me, Facebook would be faster
Okay.
rather than email, because email I may not read it every day.
Okay.
I may read the email from time to time, maybe 2, 3 days, 4 days to read email once, because I'm not full time with Luis, so I don't open email every day. But Facebook, I would answer question within a day. If you post a question in the Facebook using Messenger, and then I'll respond within a day. Is it okay?
Yeah. Sounds good.
Mm-hmm. Any other question?
No, I'm good. Yeah.
How about quiz so far?
Sorry, say again?
Quiz is so far.
Yeah, the quizzes, yeah, I think they're good.
So quizzes, you need to read the textbook. Okay, the textbook we actually list down here. You at least need to download this one, the so-called let me see, the textbook. This one, the third edition of Programming Language Programmatic. It's a PDF. We use the whole version 4, but you at least need to download this version, third edition, and then read it. Okay. So most of the quiz questions are coming from slices and this textbook. And then if you don't study, some students don't study, just jump right into the homework. It is the wrong way to do it. Okay. You should every week go to the weekly material. So here you go to the weekly material, watch the video of the week. Okay, so suppose this video you need to finish before you work on the week 3 homework. Okay, and then this week 3 we go over the name, scope, and build binding and the reference environment, because these are more than 2 hours usually. Okay, each video more than 2 hours. So on a Monday, we don't teach you this again, okay? Because we had a pre-recorded video, and also it would take a long time to finish this teaching, okay? So we actually wish students to watch the video, and then after that, there's a PDF you can download, okay, for these slices, and there are sample code. If the code is developed in the lecture, there are also sample code you can download to run them. Okay. And also you study the textbook. in the combination, in this combination, then you finish this combination, then you go to look at the question of the week, okay? But a lot of students, I believe that they never work on the video, or they never watch video, or they never study the textbook, and then jump into quizzes and figure out that, okay, some problem they cannot answer. That's actually not good, okay? Okay?
Okay, yeah, sounds good.
Yeah. And so far, I think okay. But submission of the homework is too late. A lot of students fall behind right now. Okay, we are flexible on the submission. Okay, but don't pile up too much homework, because I don't think that in the last week, last 2 weeks, you can finish everything. So it's better that you actually try to finish homework early. Okay, and those homework are actually well designed to help you to understand the subject. Okay.
Yeah, I'm all up to date with the homework, so yeah.
Yeah. Okay. So any other question?
No, yeah, I'm good.
Okay. There is no other question. I'm going to go over this lecture 3 briefly to talk about what's in here. Okay, what you will learn from here. Okay. And
Okay,
then after that, we will be dismissed. Is that okay?
sure, yeah.
So chapter 3, we are on the name, scope, binding, and reference environment. Okay. So every language have variable, and you are calculating based on those variables, and then variables deliver the result, and then you print the variables, or you actually save the variable, or you actually assign new value to variable. So they are, every programming work is basically need to deal with the variables. Okay. But variables, because they are functions, they are main programs, they are classes, the variable may mean different things. Even the same variable name may be different things. So there is a naming problem. Okay. So this chapter is talking about how variables, name, scope, binding, and environment being determined as the main topic of here. It's related to the memory model. Okay. And here we are talking about these different terms: name, binding, scope, and environment, and how the whole memory model works out for this. So this one is actually closely related to chapter 2. So first thing is name. A variable name is an ID for the variable, and there's a memory location associated with it. So you may have a variable, and then the memory location 3845 hexadecimal address code associated with it. So this name and the memory association, we call it binding. Okay, we call it binding. So binding is association of two things, such as a name and the thing that it names is a binding. Same thing, similar to marriage. Okay, same thing, similar to marriage. A husband and wife got associated together, we call it a marriage. It's actually a binding. Okay, two people binding together, we call it a binding. So here, name and the address of the variable, we have a binding. Okay, so that's the name. And the scope of the binding is called, is defined as the lifetime of that variable binding. The lifetime of binding, we call it scope. Okay. So some variable available in the main program, and when you go to the subroutine, it loses it. So that is actually local variable to the function. So we say that the scope is local because it may declare in the main function, and then when you go to the subroutine, you lost it. And then once the call finishes, you come back, the binding got restored. So binding is the association of name and memory address. The lifetime of the binding, we call it scope. Is okay? So when the binding stay in power, we call it scope. Okay, so this is the definition of name, binding, and scope. Okay, so when we do binding, there's a static binding and there is a dynamic binding, okay, especially for the functions. So C++ language has a static binding and dynamic binding. Java uses a dynamic binding all the way, okay? And then binding, when you do static, when we say something is static, means that the compiler determine it. Compiler determine whether this variable or this function associated with the memory location or the certain assembly code. Okay, that's called static binding. When you determine which function associated which function call implementation, that's static binding. And if the implementation of function find with a function name at the runtime, we call it dynamic binding. Okay. Okay, these are the time of binding. So there's also different parametric binding. Okay, these are okay. Okay, so your Python language is dynamic type, dynamic binding language. Okay. So here, this one is the strong type versus weak type, dynamic binding versus static binding. So Python is the dynamic binding but strong type, but it is not really that strong because we don't declare the data type. So it's on the border of strong type and weak type. Okay. But every data do have a type. Okay, do have a type. And then C++ is weaker type. Okay, but it's actually more static binding. Okay, C is a compiler-based language, mostly static binding. Okay, it's a binding. Okay, next one is namespace. Okay, Python namespace. So namespace, this word sometimes also called module. Okay, so it actually create a domain of environment. So some variable defined in there, we call it namespace. So inside this domain, the variable is bind with certain variable in a certain way. So we call it a namespace as a module. So here we have the LEGB rule. It's a local enclosed global and built-in 4 different scope. Okay, 4 different scope. So the variable will search for the local first. If local don't have a definition, go for enclosure. If the enclosure doesn't have it, go for global. Global doesn't have it, you search for the built-in setting. Enclosure sometimes is also a function. That means from your function block to the end of the function block is called enclosure. Local may be just a for loop. Okay. Okay, so these are the local versus global. Okay. Let me see. Okay, and there are details to define the different environment with different type of variables. Okay. The next one is the lifetime and storage management. We talk about the creation of object and the destruction of object. Okay, creation of binding and destruction of the bindings. Okay, something like that. So that's the whole memory management model you have to know for Python. So this chapter we do go into the detail of how Python memory model works. Okay, so there are a lot of things you have to study. Okay, you don't take time to go into those every detail. So there's a Copen and Copen step, and there's an epilogue and prologue. Okay, in some of the multiple choice, the answer is prologue or epilogue. Prologue means the routine work that you do before you transfer the control to a function. Epilogue means that the finished operations after the call or the function, you would like to return to your function. You need to run some procedure called epilogue. But these two words actually being tested in the multiple choice. Okay. And then study the copy collection. Okay. And the scope rule, we have the different scope rule. Okay, you need to know about how scope rule work. Okay. You need to know about how scope rule work and what is dynamic scoping. Okay. And environment. Okay, environment, this word is very important. Or sometimes we call it reference environment. So the whole set of the binding, you have A associated with some memory, B associated with some memory, C associated with some function. Those a whole set of the binding, we call it a reference environment. Is that okay? So
Yes.
with A associated with some memory location, B associated with some memory location, C associated with some function. That's called reference environment. So to know about the reference environment better, okay, there is a website you can choose to study it. And I recommend everybody to try it. It's called Python Tutor.com. Well, it's the Python Tutor.com, and then you choose your Python language. Okay, here we do have some example. Okay, there's a list, and then there's a something. So this one, let's actually do edit code. Okay, so here we do have a code, right? And that's visually wrong with it. So one statement, okay, create a global friend and then the friend detail. Next one, this number 2 is a global friend with the detail, okay, and then basically you show how different data been in the memory. So this is the reference environment that you can see. Okay, is that okay? So this one called pythontutor.com. Okay, let me put it in the chat box. This one called pythontutor.com. Okay. Any question?
No, I'm good.
And you will know that when A will be ready, when B will be ready. Okay, whatever. But you have to play this one. Okay. Okay, that's the reference environment. So you go to study what is a shallow binding, what is a deep binding. Okay, we don't have time to go into those details. Then multiple environment. So your function may have multiple environment because you have the function call and function call another function. So the when keep changing. So you will have different binding of the variables. So here it goes to it. Okay. There's some example for it. The next one is the higher order function. Okay, higher order function is a function that actually may call itself, maybe recursive, maybe a function that actually is treated as a variable to pass around. Okay, let's call higher order function. So you also need to know about when higher order function comes, what is the reference environment. Okay. And then there's a nested definition for the environment. And next one is a local name. Okay, some variables are local. Okay. And function composition. When you have 2 or more functions composed together, and then what will happen? How is the binding? Okay. This actually is for that. And some function have a self-reference, calling itself. How does a self-reference function work? Okay. So right here we go through these different functions. And there's a currying technique, also trying to understand what is currying. Okay. Any questions so far?
No, I'm good.
So this chapter is talking about what is name, what is binding, what is scope, what is the reference environment, and then applying the knowledge into the function call, currying, the multiple variable environment, dynamic binding environment. So you have to study each of the binding scope, reference environment topic in different situations. That's what we teach in this chapter. Is that okay?
That's good.
Okay. No question. We are going to stop here. Is that okay?
That's good. All right. Thank you.
Okay. See you next time. Bye bye.